theta plus sec square theta is equal to cosec square theta into sec square theta. So using identity, we should prove that cosec square plus sec square equal to cosec square into sec square. So let us take the left hand side. In the left hand side we have cosec square a plus sec square a, and right hand side is cosec square into sec square. So how we can change this cosec and sec? We know that the reciprocals of cosec square is 1 by sine square theta, and sec square is 1 by cos square theta. And now can we cross multiply? 1 into cos square is cos square theta. Now sine square into 1 is sine square theta divided by sine square theta into cos square theta. This is what we get. Now in the numerator we can make use of the identity. Since sine square theta plus cos square theta is 1, we can replace cos square plus sine square by 1. And in the denominator we have sine square theta and cos square theta. So what is 1 by sine square? It is cosec square theta into 1 by cos square is sec square theta, and that is our RHS. So we have LHS equal to RHS, hence proved. Question is tan theta plus sine theta divided by tan theta minus sine theta equal to sec theta plus 1 by sec theta minus 1. So here let us take LHS. We have tan theta plus sine theta. So maximum what we can do with this tan theta, we can write as tan theta equal to sine theta by cos theta. So here instead of tan theta, we'll write sine theta plus cos theta, and then you have a sine theta. Then in the denominator again you have a sine theta by cos theta minus sine theta, and from the numerator sine theta is common, so we can take sine theta common factor, so that inside the bracket we will have 1 by cos theta plus 1. Similarly, from the denominator also we can take a sine theta as a common factor, so that inside the bracket you get 1 by cos theta minus 1. Now what is this 1 by cos theta? 1 by cos theta means it is sec theta. Sec theta. So sine theta will get cancelled. Instead of 1 by cos you write sec theta, and denominator will be sec theta minus 1. So we got the RHS. So now we can write LHS equal to RHS, hence proved. So in this question we have root of 1 minus cos theta by 1 plus cos theta, and equal to cosec minus cot theta. So if suppose if you start with the left hand side, what we can do with this 1 minus cos theta and 1 plus cos theta, we can multiply by the conjugate 1 plus cos theta. Multiply by the conjugate means multiply by 1 minus cos theta by 1 minus cos theta, and everything inside the square root. So now numerator is 1 minus cos theta into 1 minus cos theta, which is 1 minus cos theta the whole square. And the denominator we have 1 plus cos theta into 1 minus cos theta, that is our identity, 1 minus cos square theta. Remember, everything is inside the square root. Now numerator is 1 minus cos theta the whole square. So when you take the square root of 1 minus cos theta the whole square, we can write 1 minus cos theta. Similarly, in the denominator we have 1 minus cos square theta, which is sine square theta. So in the next step I'll write root of 1 minus cos theta the whole square is 1 minus cos theta, and what is the square root of sine square theta? Sine theta. Now look at the right hand side, it is cosec minus cot. Now see whether we can make that, we can get that cosec minus cot from this. This is equal to 1 by sine theta minus cos theta by sine theta. And what is 1 by sine theta? It is cosec theta. And cos by sine is cot theta. That is what we need to prove. And this is our RHS. So we can write LHS equal to RHS. Hence, next one is sine square A into cot square A plus cos square A into tan square A equal to 1. So let us take the left hand side. Here cot square A can we write as cos square by sine square. So sine square A into, instead of cot square we'll write cos square A by sine square A. And in the next expression we have tan square A. So tan square A we can write as sine square A by cos square A. So sine square A can be cancelled. Similarly from the next term cos square can be cancelled. And what is left is cos square A plus sine square A, and that is equal to 1, the identity. So we can say LHS equal to RHS, hence proved. It is given 1 plus sine theta the whole square plus 1 minus sine theta the whole square by 2 cos square theta, and the right hand side is 1 plus sine square by 1 minus sine square. So if you look at the numerator, you have 1 plus sine theta the whole square, and also we have 1 minus sine theta the whole square. So can we use the identity a plus b the whole square and a minus b the whole square and expand? So if you expand 1 plus sine theta the whole square using the identity, it will be 1 square, which is 1, 2 sine theta plus sine square theta, which is a square plus 2ab plus b square. Similarly, 1 minus sine theta the whole square, we can write as 1 minus 2 sine theta plus sine square theta. And the denominator, let us keep like that. Look at the right hand side, we have 1 minus sine square in the denominator. So we'll change that later. So in the numerator, what will happen? 2 sine theta plus sine theta and cos theta will get cancelled. 1 plus 1 will become 2. So I can write 2. Then sine square theta and sine square theta will become 2 sine square theta. So on the right hand side, we have 1 plus sine square theta. And denominator is 2 cos square theta, but we need 1 minus sine square theta, and using the identity we can change that. Cos square is 1 minus sine square theta. And now in the numerator we have a 2 common factor, so take it outside. So 2 into 1 plus sine square theta, and in the denominator we have 2 into 1 minus sine square theta. So 2 and 2 cancel and we get the RHS, 1 plus sine square theta by 1 minus sine square theta. So we can say LHS equal to RHS, hence proved. Once you finish doing all the exercise questions from the textbook, you should definitely try these questions. More videos are coming on this topic, so stay tuned.